Thanks everyone for being here. Don't touch anything.
I won't break anything.
All right. Yeah, thanks all for coming in person and online. We got some great talks lined up today. We're gonna ask for your patience in advance with our tech here. We had a few issues, but I think we have solved them. Folks online, we can see some of you on the screen. We do want this to be interactive as much as possible. We're gonna have Maggie in the room and I'll be in the room monitoring the chat. So feel free to put some chat in, but we'd love to have discussion and dialogue too. So the room is wired for sound. So if you talk on Zoom, we can all hear you pretty well. Actually, maybe we could just get someone online just say hello, world.
Sound check, sound check.
Thanks, Bob.
Thanks.
You sound great.
So the room's pretty well wired for audio, which means that if you're not trying to be heard online, you should probably keep yourself on mute while you're having your coffee or whatever you're doing. And then yeah, we'll cruise through the day. I think the schedule will be a little flexible. We want to have time for discussion, so we'll try to keep it moving. And yeah, that's all. Is there anything else? Any other housekeeping that we should mention before we get started?
Bathrooms and emergency exits.
Emergency exits and well, you all are out here. Bathrooms down the hallway, men's room, women's room. There's coffee and pastries outside. Folks online, sorry, can't have them. Yeah. Otherwise, I don't know. Take it away, Seth.
All right, cool. So thanks everyone for coming online and in person. I think when we set this up, this is a workshop that's a function of a project that we had funded with the Army Cold Regions Research and Engineering Lab to specifically think about the Juneau Icefield as a current and future location to continue to do research. And so this workshop is a direct deliverable for that project to basically get community input into how we use the Icefield now and into the future. We ended up with over 60 responses of people that were keen to attend, whether hybrid or virtual. And I know there should be, about that many coming and going through the next 5 days, which is exciting for us to see that many people interested. We know there's actually more that are far more that are also interested. It just so happens that this corresponded with another 2 conferences of the same week, and it also happens to be break for many people. So timing, like anything, is always a thing. But I suspect we're going to have at least 60 people or more providing input into the ultimate deliverable of the workshop, which I'll talk about now. If that moves forward. See, maybe. Okay. So the ultimate goal of this next 5 days is to listen to and try to summarize as a group current science and logistics on the Juneau Icefield, and also summarize what we think we can do in the future. I have a list of topics on the left-hand side of activity that has occurred on the Juneau Icefield in the past decade or so. I've been involved with the Icefield since 2007 with Brad Markle, our other director, Andy Boucher, who will talk in a few minutes, has been involved, I think, since 2011. Is that right, Andy? Something along the lines. And we have a fairly large team that's been involved since around that time frame. And in fact, I remember a meeting. I know Bob's here. I think I remember a meeting at American Geophysical Union about 15 or 16 years ago that we had hosted at that time to talk about the Icefield is basically trying to make it more of a community resource. And that's kind of how this idea evolved over that, decade and a half. And so in the past decade, we've had a large number of projects on the Icefield that are focused on science and also infusing that science into the education activities that we have on the Icefield. So you see that list on the left-hand side. Obviously, we specialize in cryosphere research, but we've had planetary science projects that have been done on the Icefield. Some polar engineering projects have been done on the Icefield in terms of R&D of different polar instrumentation. Certainly community science experiments. And I think one of the biggest values that JERP is able to bring to our community, the Juneau Icefield is able to bring to our community is It's a very easy to access location with a lot of resources available on US soil to bring people together from different projects where we can pull resources together, merge science ideas together to get more bang for our buck and get more science done than we were each individually proposed in the first place. And the fact that we're there year after year, just like the Antarctic program for the US or other international programs or Greenland, helps us to kind of sustain this energy and keep developing and redeveloping and improving upon the tech development as well. A few years ago, this idea turned into an annual research camp that we started doing, and we've had about 35 to 40 scientists from across different institutions that have joined us on the Icefield to conduct collaborative research as a result of that. And so this workshop is kind of in light of that idea of trying to get more brain power working together on the Icefield and get more science done more effectively, more efficiently, and be more successful with that. As I said, my colleagues here, Brad Markle is our Director of Academics. I'm the Director of Research, and Annie Boucher is our Director of Operations. So Annie's going to give a little bit of a JERP background and about the logistics shortly, and Brad's going to talk about the academics, and then Brad and I are going to kind of give some examples about some of the research that's been done on the Icefield. Before I get to that, this is kind of a breakdown. I'm guessing most of you have seen the website. This is a breakdown of what we have for talks scheduled, and you'll see Monday and Tuesday we have a range of talks, and it literally covers most of the topics that I had on the left-hand side, everything from planetary sciences to cryosphere, snow science, tech R&D development, geophysics. So it's a nice wide range of topics that we're going to have discussed today, and tomorrow, which is really nice. Some here, some online. And then we have 2 days of demos, working with different instrumentation that we have here for those of us that are in person. And then Friday is a day that we have in person for those that are here, as well as hybrid, to work on a white paper that we will ultimately deliver as a public final product for this project, but also making it publicly available for the broader community to see. And so our hope is that everyone that's involved in the workshop, and obviously sharing it more broadly, we hope to get significant wide input into this white paper to make sure it kind of captures what the community thinks in terms of how we use the Icefield in the future for science and research. So with that, I'm going to pass it off to Annie Boucher, who's going to talk a little bit about the Juneau Icefield Research Program itself as background on how JERP got its start. So Annie, take it away.
Hey, I'm Annie. It's really nice to be here today with all of you. So yeah, just kind of before we start, like I think it's easy to get confused sometimes between the Juneau Icefield and JERP. The Juneau Icefield is the place, and that is open to anybody and many people who do research with JERP and many people who do research without JERP. Seth, Brad, and I specifically co-direct the Juneau Icefield Research Program, which is a nonprofit that is associated with a number of university partnerships, but is an independent nonprofit. And we facilitate education and research on the Juneau Icefield. JERP is coming up on its 80th year, which is really exciting. It was started in the 1940s by Bill O'Field, who was a glaciologist and a photographer, and his grad student, Maynard Miller. And their kind of overarching hypothesis was that the terminus retreat and advance could best be understood perhaps by studying the accumulation zone of the icefield instead of the ablation zone of glaciers. Slide, I guess. Yeah, so these are just some historic photos of research that's happened on the icefield in the last 80 years. We at one point were landing C-130 planes on the glacier, which is wild. A lot of things, throwing things out of airplanes. You can see in the bottom left, one of the over snow thigh call vehicles. We still have a few of those. We don't use them much, but they do still live in our camps and loom large in our hearts and our imaginations. Slide. Modern JERP logistics support is kind of my bread and butter. So we have a number of permanent facilities on the icefield. They're on the nunataks above the glaciers. We have 4 or 5 large field camps that can sleep up to 60 or 70 people. They have tremendous access. So this is Camp 10, right on the Taku Glacier. It's within 5 minutes, you are standing on top of Glacier itself. Our camps have a number of buildings. I'm just realizing the numbering got a little mucked up here, but we have academic space, we have carpentry and mechanic space. Every camp has cooking facilities for 50 to 70 people, lodging in a number of different buildings, and fuel containment space. So it's an incredible place to be able to fly in and just kind of have everything up and running, and be comfortable in what can be a very uncomfortable environment. It's a wet, chilly place to work in the summer. But having indoor space makes all the difference. And we spend a fair amount of time making that space available and maintaining it for people to use. Slide. One of the things JERP can offer people who want to come do research is a tremendous staff. I think these folks are the best in the whole world. We have camp staff who take care of facilities and meal organization, mechanic support, stuff like that. We have safety staff who provide alpine skills training, as well as just trail party leading and helping people navigate the ice field. We have staff in town who help everyone move around Juneau, deal with housing and groceries and helicopters in town. And our staff have direct knowledge of the program and the area going back 20 years, which is a huge thing to be able to offer people who are new to the ice field. And it's a really fun group of people. We try and maintain a really collaborative, cooperative mindset. Everyone's kind of working together, and we try and work hard and enjoy it while we're doing it. We offer helicopter support, so we have a strong working relationship with a charter company on the US side of the ice field, as well as on the Canadian side of the ice field. We mostly work out of Juneau, but it is helpful to have the Canadian access when we need it. We have people in town who are just loading helicopters, helping set up loads, working with the helicopter company to schedule stuff, and people in the field doing the other side of that, all of that. So especially for early career folks, and people who don't have as much experience in the area or don't have as much experience running their own helicopter management, we can provide a lot of support, and that's a tremendous asset and a great reason to work with JERP. Slide. We have a lot of safety equipment that's available to people. So tents, stoves, and then, camp equipment, ropes, pickets, GPSs, bear safety, fuel containment. So again, for people who aren't as experienced working on glaciology field campaigns, early career folks, JERP can be a tremendous resource. We love to give you the equipment. We love to teach people how to use it. We're kind of, our whole thing right now on the research side is to help support more research happening and to make all the tools and knowledge available that we can to help make science happen. Yeah, slide. Last but not least, we have a whole new collection of snow machines. So if you've been to JERP more than 2 years ago, you met our old snow machines, thanks to a tremendous amount of work from Seth and some grants. We have 6 new snow machines. We have people who know how to drive them. If you don't know how to drive a snow machine, we can help you do that. We have all the things you need to use the snow machines: sleds, helmets, ski racks, etc. We can deal with all the fuel for you. Yeah, I think that's all I've got. I don't know who I'm handing it off to.
And Brad's firing away now.
Off to you, Brad.
Okay. Yeah. Thanks, Annie. Thanks, Seth. And nice to get to talk with you all today. Sorry I can't be there in person, but yeah, I'm Brad. I'm the director of academics for JERP, and I'll tell you a bit about our education programs, which come out of partnerships with the University of Maine, the University of Colorado, and our local partners at the University of Alaska Southeast. So yeah, you can probably go to the next slide there, Seth. I just want to mention that a lot of people help put all of the educational programs of JERP together. Here you see our academic council, which is primarily leading and organizing our undergraduate focused education program, which I'll tell you mostly about today. It's a summer-long field school. Um, but in addition to these people, there's a lot of people that make JERP happen every year. So you can probably go to the next slide, Seth. Yeah, just wanted to show you all the numbers of students, undergrad students. For several years, we've also had a high school student program operating in Juneau that Seth has put together. Our summer-long field school mostly focuses on undergraduate students. We have about 30 every year. About 25 to 30 faculty come up and teach on that program. That's supported by a ton of facilities and field staff, as Annie was talking about. Um, and then the last few years, I wanted to mention in particular, as Seth said earlier, there's been a dedicated month of research camp operating out of our camps as well. And a couple of things have come together in the last few years. One, a really strong growing interest in our undergraduate summer school, and a huge increase in the number of external research projects, largely happening through this research camp, which has allowed us to do two, I think, really cool and important things in the last few years. One, we've been able to focus our summer field school towards undergraduates. We bring students from all types of different disciplines, but we're able to sort of focus on largely undergraduate education, but then also growing out of our growing research operations, we're going to be able to offer a graduate field school for the first time this coming summer, or first time in a long time this coming summer, which I think Scott is going to talk more about in a few minutes. So I won't talk too much more about that, but that's a really exciting development in the last couple of years. Um, I think now I'll just sort of focus on our summer-long field school that's, again, mostly targeted to undergraduates. We also have some advanced high school students. We have people who are after, have already finished their undergraduate education, or some grad students who've yet to really dive into polar sciences. Um, but our summer-long field school program focuses on these core academic themes. It's primarily a polar earth science summer school, focus on glaciology and the cryosphere. And we like to divide our curriculum into these sort of four big themes. One is primarily glaciology. What are glaciers? How do they work? We think a lot about the context of glaciers, so how glaciers interact with the landscapes around them, how they interact with the climate, how glaciers can change the landscapes, can change the climate, how changes in climate can change the glaciers. One of the really special things about our education program is we get to spend a lot of time working on the methodologies and skills associated with doing this type of science. So not just theoretically how these topics work, but students get out in the field and learn to make the measurements of these systems themselves. And then lastly, but certainly not leastly, we think about how glaciers and the ice field in particular, how they sit within humanity, how changes in climate affect people, how people have interacted with this particular landscape for a very long time. Yeah, so you can go to the next one. So as I was saying, students learn about, for example, glaciers, but the really special thing about JERP is they do so while actually going in and getting firsthand experience with how to measure these things. So we'll, for example, teach our students the theoretical basis of the mass balance of glaciers, and then they go out in the field and dig through, 5 meters of snow that fell that year to actually viscerally understand how glaciers accumulate mass. And then they'll learn about how gradients and mass balance drive glacier flow, and then they'll go out in the field and make actual GPS measurements of how these glaciers are flowing. Yeah, you can go ahead there. So yeah, just to go over some more of the topics we cover, students will learn, again, the theoretics of how, say, geophysics work, how you can use tools like GPR to image the internal structure of glaciers, and then they'll go out in the field and actually make those measurements themselves. They'll get to process the data and learn something new about the landscape that they're living in. Um, we have, in addition to getting students firsthand experience, measuring glaciers, measuring or learning about how glaciers interact with their landscapes. Here we're showing some data collected about exposure age datings of some of the nunataks that come out of the glaciers. We also, as part of our curriculum, teach our students about science communication. So on a few of these, you'll see these really nice diagrams or animations that our students have made where they've got to work with our faculty, learn about these topics of, in this case, glacial geomorphology. They'll get to go firsthand and do the research, and then they get to practice how to communicate that research both to their peers and then also to the community. We give public presentations about their summer experiences at the end of the summer in Atlin, British Columbia. So on the left, there is an animation made by a former student, UAE, about how beryllium 10 can tell you how long these mountains have been exposed from glacial retreat. You can go to the next slide. Yeah, so the in addition to just the experiential education parts about JERP, students get involved in active research. So the Juneau Icefield collects a lot of data for long-running glacier monitoring. So this includes mass balance, but also temperature records of the Juneau Icefield and surveys of the glaciers themselves. We obviously have lots of externally funded research projects that come up to the Icefield. Depending on the timing of those, students are often deeply involved in the research projects that are outside the program itself. So if you have a fun project and you come up while our students are there, you can get them involved in your research. And then every summer, our students also participate in about 2-week long sort of small research projects designed by our teaching faculty to get them sort of more deeply enmeshed in the process of designing a research question, going out in the field, collecting data, trying to answer that question to whatever extent they can, and then presenting that to their peers. Yeah, I think you can go to the next one. And then just, I sort of suppose, last to say, in addition to research towards asking very specific scientific questions, we also do work with partners for research and development of polar engineering. So, as a great example, the U.S. ice drilling program came up several years ago to test a new thermal drill. This was a type of drill that they've had, but they were developing a new version, and they came up to the Icefield to test it out. And they were able to drill, I think, 296 meters in the Icefield, which ended up being the perfect set of conditions for them to test this type of drill. They wanted to develop a system that could drill through wet glaciers. Their target was 300 meters, made it to 296 just because you needed a few meters of cable on the winch to get the drill back out of the hole. One, really, I think this is a great example of a confluence of a team coming up to test some bit of technology. We were able to combine that with our education program and get a really exciting opportunity for our students to learn how to process a whole ice core. So as the IDP team was drilling, we were able to process this 300 meters of ice and then subsequently make measurements on that ice, and then many years of JERP students since have got to look at and analyze that data and do various science projects with it. So if you go to the next slide, Seth, I'll show you all just an example of this. On the left, students are using some ice flow models to try to understand how old this ice core that we drilled at the Mathis and Llewellyn Glacier Divide with IDP actually is. So, those images on the left are students doing some depth age modeling, testing sensitivities. And then, as I said, we measured a bunch of aspects of this core. For example, the water isotope ratios are shown down on the right. And students in subsequent years from that test have been able to look at that data, and we've found some interesting things. For example, it's a little bit hard to see there, but we're finding evidence of meltwater that accumulates in the firn on these glaciers is altering the geochemistry that's measured in the ice there. I think this might be my last slide, and I'll pass it off to Seth. But just to sum up, our education programs are pretty unique. We immerse students in polar sciences, and we get them deeply involved in research, both small research projects that they complete with their peers, but also are involved in large external outside research projects as well. I think for these reasons, the program is often our students almost universally say they've had an outstanding experience at the end of the summer, and for a lot of them, it changes the course of their academic lives. I think that's about it. I'll pass it off to Seth.
All right, so thanks, Brad. So I'll finish up with a few more research examples trending from the training side. But I think one common theme is that merger of workforce development and doing real science. And I think one thing we'd like to share about that drilling project that Brad mentioned, I think the total cost was like a $30,000 budget to get a just shy of 300-meter core. And for reference of scale, the 200-meter cores that we drilled on Denali back in 2013 was about over $1 million. So, we're really getting this big bang for our buck with training, with workforce development for our next leaders in Arctic sciences on the Icefield, while getting a ton of observations. And that's really one unique value that the Icefield can bring to the science community, and that's what we're keen to kind of share with the community. So I'll give a few other examples of things we've worked on very quickly, because we're very close to out of time, and Scott's going to jump in here really quick for his talk. This is an example that we work with a group from MIT that developed a couple GPS and seismic station that could be kicked out to the side of a plane from about 5,000 feet, penetrate into the ice, and start measuring ice motion. That it was designed and funded. It was funded by NSF, designed to install on Ross Ice Shelf. Way cheaper to test it on the Juneau Icefield, and so that's what they did the first year, is come to the Icefield and test it with us, and it worked. They worked out some kinks that first year, and they actually picked it up last year. It successfully was deployed at Ross Ice Shelf. So it's another good example of significant cost savings, as opposed to going to Antarctica to do this project, doing it on the Icefield first to kind of do some R&D with the system before they actually deployed it. The Icefield's a great location to kind of look at snowpack and firn properties too. So that's what a lot of us are looking at. You can think about this model that Kaylee Manello made that kind of captures more meltwater, the lower elevation you're at, those little dots in the accumulation, the snow accumulation. As you work your way up glacier, you have less meltwater. Well, that spatial and temporal variation in meltwater is a big question for many of us in the cryosphere community when you're looking at snow, when you're looking at firn, and when you're looking at ice. You can see a radar profile that we collected a number of years ago, kind of showing that glacial structure and snow accumulation. You can see a firn aquifer in there. So quite a significant amount of variability. And we're able to go to these places and study these places year after year and capture a lot of variations. And so this is a data set that Tahi Wiggins led a few years ago, trying to use terrestrial radar interferometry, showing a change in coherence over 5 hours of data collection. And also what we think is melt-induced surface lowering in areas that we would expect higher melt. And you're talking about really low, like really small changes, in the millimeter scale changes looking across these surfaces. And we're trying to relate that to what we see in terms of the snowpack properties themselves and the subsurface. So swapping again to some of Kaylee's work, she published this last year on the Icefield, where we have a time series of accumulation on the Icefield that date back to 2012. We've been collecting data annually there. So she published a nice paper kind of comparing 2012 to 2021. And now we're shifting towards building a time series of changing structures. So this is a neat GIF video that she had between a couple different weeks of data collected on the ice field. And you can see the change in the structure of the ice, which is predominantly caused by the meltwater in the snowpack, driving that change. And so this was common offset data. And then, using multi-offset ground penetrating radar data has been the next generation. This is a system that we started using a few years ago with some of the Army funding. And this was supported by Keegan Bellamy, her master's work, and Dave Meehan, who works for the Army Cold Regions Research and Engineering Lab, to kind of capture, again, that time series of spatial change, which is something that many of us are interested in across for the community. With that, I'll shift it back. I'll finish my time here, and we're going to get to Scott, so we don't get too far behind schedule already. Again, I hope everyone thinks about how we might use the ice field collaboratively over the next 2 days and the next 5 days, and that's what we really want to capture in this white paper, and what science topics we really want to focus on moving forward, and what we can do to see that happen. So I think with that, I'll take any questions. Actually, we're going to hold questions. I think we're just going to dive right into Scott.
I'll have time for questions that.
Okay.
We do it.
All merges.
Great.
Well, let's switch it over with these questions.
Okay, cool. So I'll take any questions right now. Anyone online, if you do have questions,